Welcome to another exciting educational video brought to you by Vision Concept Academy. Today we'll be looking at a series of questions from NECO maths questions. We'll be sampling the 2023 exams, and I have a question on the board. I will dive in straight here to the question. It says simplify 6y squared all raised to power 3 divided by 24y raised to power 6. So the first thing we'll do is to write it in quotient form. I have 6y squared, then raised to power 3 all over 24y raised to power 6. So I can break this one down. This one is the same thing as saying you raise the power of what you have inside here as 6 raised to power 3, because this power 3 is acting on both 6 and y squared inside. So I say 6 raised to power 3 and y raised to power 2 times 3, okay, all over 24 y raised to power 6. Okay, so we'll continue saying the same thing as saying 6 times 6 times 6 in 3 places over 24 dot y raised to power 6 all over y raised to power 6. So this will cancel this. One of these 6 here is 1 here. 6 into 24 is 4 times. So I have 2 here, 2 here, 3, and 2 here, 1, 2 here, 3. So I have 3 times 3, 9. That's the only one that is we have here, and we don't have any other one downstairs. So the answer is 9. So we have succeeded simplifying this to this. So we'll move on to the next question. Okay, so I have question 1b on the board. It says solve log to base 10. 2m squared plus 5m minus 2 is equals to 1. Okay, so you know that we have to convert this log to exponent. Remember, if we have log a to b to base a is equals to 1, it is the same thing as saying this one goes up, b is equals to a raised to power 1. This is what we're going to be using. So I will convert this to exponent. Convert this to exponent. When I do that, this one will remain as it is. So I have it as 2m squared plus 5m minus 2 is equals to, then this 10 will go and raise the 1 there to the power. So when I do that, I have 2m squared plus 5m minus 2 is equals to 10 raised to power 1 is 10. So I still have it as 10. Okay, so I can bring this constant term to this side so that I will have a quadratic equation. So I have 2m squared plus 5m. When 10 goes, it becomes minus. Minus 2 minus 10 is equals to 0. Of course, 2m squared plus 5m minus 12 is equals to 0. So at this point, I have a quadratic equation. So I'm going to use quadratic formula to solve this, where a is equals to b, where a is equals to 2, b is equals to 5, and c is equals to minus 12. So using the quadratic formula that says that the root of this equation is minus b plus or minus square root of b squared minus 4ac over 2a. Okay, so I'm going to divide this board into 2 so that I can finish up my calculation. I'll continue from here. I'm going to be getting 2 roots. So I'll define what a is from this expression, what b is from this expression, what c is from this expression. So I'm going to plug them into this formula. So I have minus b is minus 5 plus on minus square root. B again is minus 5 square, that's from here, then minus, I'll use my dots to represent 4 dot a is 2 dot C is minus 12. Okay, all over 2 times A, 2 times 2 is 4. Okay, so I continue from here. Minus 5 plus or minus the square roots. So this minus 5 square is 25. Then this is minus and minus here. Minus minus will give me plus. Then 4 times 2 is 8. 8 times 12 is 96. 96 all over 2 times 2 is 4. So I'm working towards getting 2 roots. 2 roots. Okay, so minus 5 plus or minus. If I resolve these two, 25 plus 96, I get 121 all over 4. So I said minus 5 plus or minus root 121 is 11. So 11 over 4. So I can split these two expressions like this. I have either 5 plus 11 over 4 or minus 5 minus 11 over 4. The splitting comes from this sign here. This sign, there are two signs here. So either I work with the plus sign at the middle here, or I work with minus sign at the middle here. So I have two roots. So minus 5 plus 11, minus 5 plus 11 will give me 6. So I have 6 over 4, or minus 5 minus 11 will give me minus 16. Minus 16 over 4. So there are two possible answers here. I have either m, because I'm looking for m. M is equals to 3 over 2, or 1.5, or minus 4. So these are the solutions for m. So, so the answer to this is either of these. So if you are asked to find, if in the question it is specified that the m should be positive, so you choose m as positive. Understand? That is 3 over 2. But this is, they say we should just find the value of m from here. So these are the two possible answers for that question. So we'll dive on to the next question. Okay, so I have here, say if w varies directly as the cube of roots, the cube roots of d, and w is equals to 10 when d is equals to 27. Find the value of w when d is equals to 64. The first thing we'll do, we know that this is what we call direct variation. Direct variation. So the first thing is to do is to write out the formula for direct variation. Is given as w. Okay, let me divide the board into two. So I have w varies directly as the cube root. So this is what the cube root of d. Understand? So by the time I remove this proportionality sign, I introduce my constants and put the equals to. So k is equal to k root cube root of 3. Yes, that's it. Okay. So this is not square, just cube roots. Very good. So I can now put the relationship. So when for the first statement, I have that if w varies directly as the cube root of d, and w is equals to 10, yes, when d is equals to, yes, this is the first relationship. So with that first relationship, if or when w is equals to 10, comma, d is equals to 27. So I can find what k is from here. So I can come here and say w is 10 is equals to, then k is not known, then the cube roots of 27. Okay, so I can get k invariably 10 over cube root of 27 is equals to k. So what would that give us? This cube root of 27 is 3 already. Therefore, k is equals to 10 over 3. So this is the constant. So this constant, I'm going to use it to test the second relationship. It says that we should find the value of w. So now we're still going to bring this one again and say w is equals to, then k, then cube roots of d. Cube root of d. So we're going to be finding the value of w when d is equal to 64. Already we've gotten k from the first relationship. So W here is equals to, what is K? 10 over 3, then times the cube roots of what? 64. W now is equals to 10 over 3 times 64 cube roots will give us 4. 4, because by the time you multiply 3 times 3 times 3, sorry, 4 times 4 times 4, 4 times 4 times 4 will give us 64. So that is why the cube root of 64 is 4. Okay, so at this point, by the time we compute, we are getting approximately 13.3 and continuous. Okay, so that is for W. Okay, so we have question 2b on the board. It says solve the simultaneous equations x over 2 plus y over 6 is equal to 2 over 3, and x over 3 minus y over 2 is equal to 5 over 3. So there are two equations with two variables, x and y, We will solve them at the same time. That's why we call it simultaneous equation. We'll solve them at the same time to get the values that will make x and y equal to this in one instance, and x and y equal to this in second instance. Okay, so well, x and y, no, this component and this component equal to this, and this equal to this. Okay, that's it. So the first thing we'll do is to take a deep breath. Take a deep breath and look for how to make these fractional cases. Look for how to make them just linear cases, that's number without fractions. So what will I do? I will divide each of these terms by 6. So I will come here and say multiply each term by 6 to eliminate the fractions. Let me just put the statement there. Okay, multiply each term by 6 to eliminate the fraction. Why am I using 6? 6 is not an arbitrary number. I'm looking for a number such that when I do the multiplication on each of the terms, I will not get a fraction. And that number is 6. 6 is the least number, the least common multiple. Okay, so I will start from equation 1. I will put a 6 here. I will put a 6. I will multiply it by the first term, then plus a 6 again, multiplied by the second term, is equals to 6 again, multiplied by the third term. See, these are the terms. This one is this, this one is this, this one is this. So what I'm doing is that I'm multiplying each of them by 6. I'm not cheating anybody. It's a fair thing to do in mathematics. Same thing I'm going to do in the second equation. I'll multiply each term by 6 again. Second equation. So I'll bring 6 outside, multiply this one by 6, minus multiply this one by 6, and multiply this one by 6. Again, I'm being fair. I'm using the same number to multiply each term. I'm not cheating anybody. I'm not giving this one 6 and giving this one 3. I will make sure I use the same 6 throughout and 6 throughout. I can decide to use 6 here and something else here. But whatever you are using to multiply each of the terms is for you to ensure that the fractional cases become just number that I want to eliminate the fraction. So looking at the first equation here, if I say 2 here 1, then 2 here 3, again 2 here 1, 2 here 3, again 2 here 1, 2 here 2. So I'll just multiply through. 3 times x is 3x plus 3 times y is 3y is equals to 2 times 2 is 4. This is equation 1 transformed. Then equation 2, 3 here 1, 3 here 2. So I have 2x, 2 here 1, 2 here 3. I have minus 3y, and 3 here 1, 3 here 2. 2 times 5 is 10. So this is equation 2. So I have now gotten two equations. I have now gotten two equations that I will now solve simultaneously. I will solve simultaneously. So at this point it's easy. I can just do a line under here like this so that I can do subtraction. Okay, let me do addition. So I'm going to be adding two equations on the two equations to eliminate this constant, this y10. We want to do operation. We want to do on this side on the two equations. I'm using elimination method. Now, for elimination method to work, you ensure that the coefficient of either of the two variables, you understand, either of them is the same, and the signs can cancel out if you apply a particular operation. Two conditions for me to use elimination method properly. The first condition is that I look at this coefficient of x here, x and x, this is 3 and 2. I cannot readily apply elimination on this particular term. If I look at this one, coefficient of 3, y is 3 here, and coefficient of y here is 3 here. So I can actually eliminate these two if I use either multiplication, either subtraction or addition. But at this point, I can see too that the signs in front of them, for this one I have plus, for this one I have minus. So if I use plus, invariably it is 3 minus 3. So plus operation applied to these two equations will eliminate this particular term. Plus operation applied to this particular two equation will eliminate this particular term. So if I say 3x plus 2y, sorry, 3x plus 2x, I have 5x here, right? Then 3y plus minus 3y, the same thing as saying 3y minus 3y, I have 0, then equals to 4 plus 10, will give me 14. So I'm gearing towards getting my first term. Okay, so I'm gearing towards getting my first term, but I noticed that there is an error in the question, that's interpreting the question in my calculation. See this question here, look at what the mistake I'm making here. So this is supposed to be y over 6, not y over 2. So if this cancels this, I don't have a 3 here, I only have a y. That means I have a y here. So that means what I'm doing now will not suffice if I have these two equations. If I have equation 1 as this and equation 2 as this, so I'm going to look for another method to solve this other than the elimination method I'm trying to do. So if I still want to use the elimination method, see what I'm going to do. I'm going to multiply first equation by a constant and second equation by a constant, so that I can get a particular, the two equations having similar coefficients. Or the cheaper way to do it is to use the substitution method. So I can come here and say from equation 1, this equation 1, I can say make y subjects. If I make y subjects here, y is equals to 4 minus 3x. All right? So let me just call this equation 3 because I have transformed equation 1 to that point. So I can now say substitute equation 3 in 1 in equation 1. How am I doing that? How am I doing that? So equation 3 in 2. In 2. So this is 2. I used 1 to make equation 1 to make y subject the formula, right? So I'm going to use this, what I've made here, and put in 3 to get x. So I'm going to write this equation 2. Okay, I will write it. I will say 2x minus 3. So instead of having y, I'll just open a bracket and put what y is defined as here, 4 minus 3x. So this is actually y is equals to 10. Okay, so I can now simplify this algebra. 2x minus 3 times 4 is 12. Okay, then 3 times 3 is plus 9x. Okay, is equals to 10. So this and this is 11x is equals to 10 minus or plus 14. 10 plus 14. Okay. Okay. So it's going to be 2x plus 9x is 11x. Then 10 here. Then minus 12 will go and meet 10 and it becomes plus. So I have 11x is equals to 10 plus 12 is 22. So therefore x is equals to 22 over 11, which will give me 2. So if I have x as 2, I can now get y by substituting in this expression. So in equation 3, I have y is equals to 4 minus 3. Instead of having my x there, I put 2. So y is equals to 4 minus 3 times 2 is 6. So 4 minus 6 is minus 2. So I have x as 2 and y is minus 2 as the answer. So you can always do this check. You can do this check. This is x 2 and y is minus 2. Do this check. When you put this inside this expression, it will balance. If I put 2 here and I put minus 2 here, I will get this particular one. So we'll move on to the next question. Okay, so I have this question on the board, number 3a. It says, find the sum of the first 8 terms of a GP, geometric progression, whose first term is 5 and common ratio is 3. So I can first start by bringing out the parameters. For GP, sum of terms is given as for r is greater than 1, I will use sum of n term is a then dot r raised to power n minus 1 all over r minus 1. So this is the formula for the sum of terms if r is greater than 1. So from the equation, from the question, we are given the parameters a, first term, as 5, and the common ratio r as 3, and number of terms n is equals to 8. So this is simple enough. So S8, meaning sum of first 8 terms, is equals to, so I put my 5 here, 5 dots, then I have 3 common ratio, then n is 8 minus 1, then all over 3 minus 1. Okay, so this 5 is multiplying everything outside. 5 times 3 to the power 8 will give us 6561 minus 1 all over 3 minus 1 is 2 here. Okay, so S8 is equals to 5 times this minus this is 6560 all over 2. All over 2. So I can still say 5 times, when you divide this, you have 3280, and S8 is equals to, by the time you do 5 times 3280, I will have 16400 as my answer. Okay, so move on to 3b. So I have the question on the board. It says that a plank leans against the top of a building at an angle 30 degrees, okay, to the horizontal. Okay, so let's just draw this. So the plank, top of the building, first of all. This is the building. Of course, the building is standing on the ground, right? So the plank is leaning on it. They said top. So let me reduce it to this. Okay, so the plank is leaning against the top of the building, okay, at an angle of 30 degrees. So this is the angle, 30 degrees, to the horizontal. Okay, so see the description. The plank, this is the plank, is leaning 30 degrees to the horizontal. Okay, so this describes this diagram. And the building is how many meter high? 12 meter high. So what is the length of the plank? So this is the plank now. Let's call the plank A, B. The plank is AB, and let's call this part C. So this is a typical case of a right angle triangle, and the relationship we're going to be using here is trigonometric identity, trigonometric ratios that seeks to deploy the use of the sides of right angle triangle and one of the angles or the angles to find another parameter. So we see that from here we have definitions of the various sides. You understand? The various sides. The definition takes its name from the angle of reference. So if 30 degree angle of reference, this guy here is the opposite. And if 30 degree is the reference, this guy here, the plank, is the hypotenuse. And of course, the distance between the plank and the ground is the foot of the building is adjacent. Just everything came from this angle, because if I come here and start referencing here, all these things will change. So please take note in trigonometric ratios, the names of the sides of the right angle triangle is derived from the position of the angle. Okay, now I have this angle, I have this side, the opposite, and I'm going to find here. So I just have one particular identity to use. So from your SOCATOIS, which is a way of remembering these identities, you see that the ratio that has both opposite and hypotenuse is sine. The ratio that have both opposite and hypotenuse is sine. So I'm going to be using this one, so is sine theta s is equals to opposite O over hypotenuse h. So this is what I'm going to be using to solve this. Okay, so sine theta, what's theta here? 30 is equals to opposite is 12, hypotenuse is not unknown. So I'm looking for hypotenuse. So all I have to do is to just multiply, just make hypotenuse out of the formula. So I have 12 over sine 30. So hypotenuse will now give me, after my compute, it will give me 24. 24. Okay, 24. So the length of the plank is 24. All right, 24 what? Meters. Please, always know your units. Okay, go to the next question. Okay, so I have a question on the board. It says the volume of a hemisphere is 1527.4 cm cubed. Find the radius of the hemisphere to the nearest whole number. Okay, so this is just testing us of the ability to, or the expertise to understand shapes, volume of shapes, which part of your the curriculum for your NECO exams. So volume of hemisphere V is given as 2 over 3 pi r cubed. Pi r cubed. That's the volume of a hemisphere. So this is simple enough. Once you just know this formula, you have gotten this question. So the volume is given already as 1527.4 is equals to 2 over 3. Then this is given as 22 over 7, then times r cubed. So this is what we are looking for, r. Okay, so we can do the maths. Just make r as a formula. That's what I will do. Multiply this by this and divide by this. So I have 1527.4 times 3 times 7 all over 2 times 22 is equals to r cubed. So all of this one, by the time you compute this one with your calculator, you just say this cube roots. The cube roots of 1527.4 times 3 times 7 all over 22 times 2 is equals to r. So r, by the time you finish everything, you'll be getting r as 9 cm. 9 cm. So it's simple enough. Okay, so finally for this segment, we have solve for y if 3 raised to power 3y plus 1 is equals to 81 minus y. So this is equation by indices. So what we do is to make find a way to make these two sides of the equation have the same base. So what do? We just express it like this: 3 raised to the power 3y plus 1 is equals to, this 81 can be expressed as 3 raised to the power 4. Okay, so times minus y. Okay, so at this point I have it as 3 raised to the power 3y plus 1 is equals to, so this is 3. The minus can come to the root of 4, so minus 4y. So at this point I have it as the same base. So since we have the same base, we equate the powers. What does that mean? So I have 3y plus 1 is equals to minus 4y. So I can make y subjects of formula. So I have 3y, when minus 4y crosses, it becomes plus 4y is equals to, this one goes to that side, minus 1. So 3 plus 4 is 7y is equals to minus 1. So finally, I have y is equals to minus 1 over 7. That's the answer. So I hope this video has been informative for you today. I'd like to thank you for viewing.